All right, I want to start this section on absolute value equations with a brief example first. You've seen absolute value in the past, and so if we had the absolute value of x plus 2 is equal to, let's say, 5, we know that this quantity, whatever is inside of here, can either be a positive or negative. If it's positive, then it is equal to, so if it's positive, then it's going to be x plus 2 is going to be equal to positive 5. However, if the quantity in x plus 2 is actually negative, then whatever x plus 2 is equal to negative 5. We'll kind of multiply the left side by a negative, and really if we're saying that this quantity in here was actually negative in the first place, then we're multiplying both sides by a negative, and that's why we get the negative 5 over here. But we end up with these two different equations. The what if this was positive and the what if this was negative, and we go through and solve. So here we have x is equal to negative 7, and over here we would have x is equal to 3. And we could graph both those on a number line with 0. Over here we'd have 3, and over here, right around there somewhere, we'd have negative 7. So we just graphed two solutions, 2 points, on our number line. Now, keeping that in mind, want to go back and actually now take a look at those the examples we had just a second ago. All right, let me clear this up. Or the examples we have on your note page. Sorry, let me find my mouse here. And so absolute value equations are sentences with the absolute value symbol here. And we just talked about this first one. What if the absolute value of some number is equal to c? Then depending on, well, let's say it was the absolute value of x is equal to 3, for example, we know that x is either positive or negative, and if it's positive, then x is equal to 3. So you'd either have 0 here, and then for this graph right here, it would be at c, wherever that's at. And if this value in here is negative, then it's equal to negative 3, or for this example here, negative c. There's our two solutions. X is equal to either c or equal to negative c. Now when we get in here to inequalities, it's going to be real similar to the example we did at the very beginning of this video. Let's set absolute value of x. This time let's have it equal or less than 3. So remember, this quantity in here is either positive or negative. If it's positive, then we know that x is less than 3. However, if the quantity is actually negative, then we've got x is, well, hey, this is going to be multiplied by a negative here. So x is greater than negative 3. X is greater than negative 3. And this is going to be our the situation where we have an and. Now we're going to have ands and ors, and this is our and. So we're looking for both kind of are true in this case. So we've got 0 on our number line here, and I'll graph the first one that x is greater than negative 3, or I'll go back to c here, so negative c, and it's going to be greater than, heading off to the positive numbers. And the second one, where x is less than 3, so here's, or c, first back in our abstract example, and we're looking for ones that are less than. I should have included a open circle back here on the first one because there's no or equal to sign. And it's going that way. And so we're looking for the solution where both are true, and that's going to be kind of in this area here in the middle. That between negative c and c, all those values are what makes this absolute value inequality true. Numbers over here like 2, if it was 3, because 2 is both less than 3 but greater than negative 3, and once we get outside of those boundaries, that it's no longer true. The last one here is going to be our or, where either one ends up being true. And so let's play around with that one for a second. If we have the absolute value of x is greater than, let's say 3 again, well, if this x value is positive, then we have x is greater than 3. However, if it's negative, we have x is less than negative 3. Here's 0, here's c, here's negative c rather. Now let's graph this one first. If x is less than negative 3, or negative c, those are the ones heading off to our top to the left. Those are our negative values. And if x is greater than 3, or greater than c here, it's heading off to the right. And there's no crossover. Again, this is why it would be an or. We're not looking for where anything is true. We're looking for either one right here. So x is less than negative c, like our negative 3 over there, or greater than c. All right, we'll finish up this second box here in just a second.